and welcome to this session of the video series, which is going to be an enabler for you to be mastering the mother of all programming languages. Well, in the previous session, you were able to understand and appreciate the fact that even though C language happens to be a programming language that was released way back in 1972, but then is relevant even today, and thanks to Corona that it has also raised itself to the #1 spot. But then what I would also wish to tell you is that C language has always been amongst the top 3 programming languages, which only goes to show how important it is for anybody who really wants to understand the field of programming and the field of computer science to actually have a mastery over this programming language. Also, in the previous session, this was the program which you made an attempt to understand. Though at a superficial level, you are able to understand as to what really the program is doing, but then what is actually happening at the grassroots? How exactly does a C program get executed? What are the various elements present in this program which really is contributing in computing the area of a circle? Well, there is a lot for you to be understanding in this session. So let's dive deeper and try understanding the mother of all programming languages in greater depth. One input which as a learner that you really will have to understand is that whenever you are going to write the program in any given programming language, it is very important for you to be abiding the rules of that programming language. Well, forget about programming languages. Don't you think even when you are going to be using English for communication, don't you think you have to abide by the rules of the English language? Not just the English language, be it the Kannada language, be it Hindi, Tamil, Telugu, that way a host of languages that exist, the languages which are there for the sake of communication. Don't you think that when we actually make use of these languages for communication that we have to abide by the rules of the language? You cannot obviously make use of the language whichever way you want. The rule holds good not just for these languages which we use to communicate with human beings, but also the same rule holds good for programming languages as well. After all, you know that programming languages are languages which are used not to communicate with other human beings, rather to communicate with the machine. And obviously, whenever any communication has to happen with the machine through the programming language, it becomes important for you as a programmer to abide by the rules of that programming language. This program is indeed abiding the rules set by Dennis Ritchie for his programming language, that is the C language. You know, the one that begins with the hash symbol, we call it as the preprocessor directives. And after the preprocessor directives, according to the general structure, you are supposed to have the global variables. Of course, at this point in time, there is no need for global variables, which is why we don't have any global variables there. But then every C language should have a main function, and that's precisely what we have there. And then the local declarations. Of course, whenever you are going to have the local declarations, since C language happens to be a statically typed programming language that you should not just declare the variables, you should also be providing the data types of the variables, and then of course you should have the executable statements as well. Well, I am definitely sure that not all the terms that are used here are completely clear. Anyway, you would get to know about each one of them, but then I think all of you understand and appreciate the fact that we have not written this program whichever way we want. We have definitely abided by the rules set by C language, by the rules set by Dennis Ritchie. But then if you'll ask me, is this the only way to do coding? Is this the only way to actually compute the area of the circle? Well, you know that we can actually do it in many ways. Definitely this happens to be just one of the ways of doing it. For example, I can actually make changes in this. Yes, I am sure that you are awaiting to hear from me more about the preprocessor directives, maybe more about the data types, local variables, global variables, and all of this. Anyway, I would be communicating all of that, but then I would wish to provide very quickly 2 variants to this program and then dive deeper to dissect as to what really is there within the program. Now, the first variant is something like this. You know, you have a constant there in your program. Don't you think pi happens to be a mathematical constant and its value is 22 by 7. Well, that 22 by 7 has been factored in our program as 3.141, but then definitely the value of pi, the actual value that way is this. Yes, it is a recurring number that way, but then for the sake of simplicity, we have taken the value of pi as 3.141. And let me tell you, as a good programming practice, whenever there are constants in your program, it is better to not hard code the constant value the way we have done in the program. There is another better way to do it. And if you'll ask me, what is the better way to do it? Well, all that I will have to do is to remove that 3.141 from there. Well, I am sure the moment I remove 3.141, the learners would be really perplexed that the formula now doesn't hold good at all. That area is not equal to radius into radius after all. It is pi r square, right? Well, what I meant to say is that you have to eliminate 3.141 from there, but then you can use a preprocessor directive like this. Yes, in the beginning of the program itself, I am making use of the hash define preprocessor directive and I am defining a constant called as pi as 3.141. Well, if you'll ask me, now would the program work? Well, you have done only 50% of the task, wherein you have now created a constant called pi using the hash define preprocessor directive. But then what you now have to do is to have here as pi. And now I am sure that you agree that the formula definitely holds good, and now I am also sure that it is needless for me to say that whatever newly you have brought in, that is the hash define, after all is beginning with the hash symbol, and hence you know it happens to be a preprocessor directive. Well, I do understand that at this point in time you may not know what really is the role played by hash include. You may not know as to what really is the role played by hash define, but at least this thing you know that it happens to be a preprocessor directive because all preprocessor directives begin with a hash symbol. Anyway, moving ahead, I would definitely tell you as to what a preprocessor directive is and what really is the difference between a hash include, a hash define and a host of other preprocessor directives. But then I am sure now you've been able to understand this second variant of the program. Anyway, does it work? Let's check. Presuming that I have coded this program on this editor, all that I will have to do is to execute it. But then we will also have to compile before execution. Well, I am sure for those who have watched my video series on core Java, which is also one of my recommendations to you, you would have understood that the program which we have coded is in a high-level programming language like the C language. But then the machines, or in other words, your computer definitely doesn't understand this high-level programming language because you know that it is more of English-like statements that you have there. Definitely what the machine understands is only zeros and ones, which means that it is your responsibility as a programmer to convert this program which you have coded in a high-level language like C into a binary language, or in other words, a language of zeros and ones. Well, why should you convert it to zeros and ones? That's because the machine, or in other words, your computer understands only zeros and ones, and that process of converting the high-level language code into the machine-level language code is what we refer to as the compilation. And all that you have to do is to click upon this and then you would be able to complete your compilation. And as you can notice, there are no errors, there are no warnings, which means that definitely you are now ready to execute the program. Obviously, you would have got the program in the form of zeros and ones, and definitely I would speak more about this program which you would have got in the form of zeros and ones, and I would also show that program which is in the form of zeros and ones to you moving ahead. But at this point in time, what is important for me is to check if really this modified program is going to execute or not. And all that you have to do if you want to execute is to click upon this. And upon execution, as you can notice, we indeed are getting the same output. In other words, what I mean to say is that this was the first approach in which we coded, and then this is the second approach in which we have coded. And if you'll ask me which amongst the two approaches is really good, well, I would prefer the second one when compared to the first one. Well, the moment I tell that I prefer the second one, I'm sure there could be a few doubts at the back of your mind that what is really great about the second one. Well, what really is great about the second approach is something which you would get to know when I would be taking up the session on preprocessor directives. But then out of the two approaches, definitely the second approach is a better approach. But then if you'll ask me, is there a much better approach? Yes, that I would be calling it as the third approach. Now, why do we need the third approach? What really is the limitation in this approach, that is the second approach? Let me tell you. Well, the limitation of this second approach, you would get to know when you are actually looking at how really we are compiling and executing it. What I mean to say is that, say, supposing the same program wherein I have the radius as 5.0. If I really want to execute it, then firstly I need to compile it. So I would compile it and then I'm going to execute it and I've got the result. But then what if you want to compute the area of a circle whose radius is 5.5? Well, what you really would now be suggesting me is to go to the source code, remove this 5.0, put in a 5.5. Well, now that you have made a change in your source code, obviously you cannot execute it directly. You need to first compile it. Well, upon compilation, as you can notice, we have got it as 0 errors and 0 warnings, and then I have to execute it, and obviously upon execution, now what you have got is the area of a circle whose radius is 5.5. But then what you really have to make note here is that because you made a change in your source code, because you changed this 5 and made it 5.5, the next time before execution, you have to compile it and execute it, and obviously compilation is going to consume your time, right? Well, let me actually make it even more clear to you by asking this question. What if you want to compute the area of a circle whose radius happens to be 100.5? Well, again you will suggest me the same thing, that in this source code, remove the 5.5, put in a 100.5, and then obviously I cannot execute it straight away. Because you have made a change in your source code, you need to first compile the program. And let me again caution you that compilation always is going to be time consuming after all. Anyway, I have to compile it, and upon compilation, as you can notice, we get 0 errors and 0 warnings, and then I will have to proceed ahead and execute. And when I'll execute, I am indeed getting the new area, and obviously it happens to be the area of a circle whose radius happens to be 100.5. Anyway, what I want you to understand is that this approach 2 happens to be such an approach wherein as and when you change the radius of the circle, it demands that you have to compile it, and only after that you need to be executing it. That is the limitation. Well, if still the limitation is not clear, let me actually set out my expectation in the approach 3. I want to design a program such that whatever be the radius that I would be willing to give, I should be able to give, but then I would be compiling my program only once. Any number of times I would wish to execute, I would execute, but then compilation should happen only once. Well, that is the kind of program that I would wish to write. In the second approach, no doubt you can compute the area of a circle with radius 5.0, with radius 5.5, with radius 100.5, but then each time you have to compile and then execute. Compile and then execute, and obviously it is time consuming. In other words, this happens to be the limitation of the second approach. My third approach is going to be such an approach wherein I am just going to be compiling my program only once. I can execute it with different values of the radius every single time, but then compilation would happen only once. I am sure now you are interested in knowing as to how really we can be coding the program that way, wherein we would compile it only once, but then we can execute it with different values of radiuses to get the different values of the areas. What is that third approach? Let me tell you.